So we're going to be solving equations today with variables and constants on both sides of our equation. We're going to start with what most of the time I just call these two-step equations. I do have in both of these equations, I have a variable term on one side, but I have a constant term on both sides. So we're always trying to isolate this variable. So we're just going to undo everything that is happening to that variable in the reverse order of PEMDAS. So I'm adding 8 and I'm multiplying it by 2. So I'm going to go in reverse order of PEMDAS. So I'll start by undoing the addition. So I will subtract 8 from this side. And if I subtract 8 from this side, I have to subtract 8 from this side. And so then I will get 2x is equal to negative 36. And then I am multiplying x by 2. So to undo that, I would divide by 2. And I'll get x equals negative 18. And then to check it, I can take negative 18, plug this into my original equation, and do 2 times negative 18 is negative 36. Add 8 to that, and I'll get negative 28, and that's the same as this side, so it does check. So this is my solution here. And we'll move on to the next one. So I've got my y on the right-hand side now, my variable's on the right. So I'm going to undo everything that's happening to the y. So I'll subtract 9 from both sides. And this will give me 26 equals negative 13y. And then I'm multiplying y by negative 13. So to undo that, I would divide by negative 13. And then I would get y equals negative 2. And again, plug that back into the original equation to check. And these are solving equations are great when you're taking a quiz or a test, because you can verify that you got the right answer by plugging your answer in or your solution into the original problem. Okay, so let's look at some other ones here that may have maybe some variables on both sides, and then we'll look at another one that has variables and constants on both sides. So this one has variables on both sides. So I need to decide which side do I want to put all my variables. And be strategic about this, because on this side I have a variable term. On this side I have a constant and a variable term. So since I already have a constant on this side and a variable term over here, I'm going to take this variable term and I'm just going to move it over here by adding 2x to both sides. What that'll do is it'll put my variable term on this side, and then I'll have my constant on this side. So I'll have isolated my variable term over here. So I'm subtracting 2x from both sides. So to undo that, I'm going to add 2x to both sides. And that'll give me 11x is equal to 44. And now that I have all my x's on the left and my constants on the right, I'm just going to undo what's happening to x. I'm multiplying it by 11, so to undo that, I will divide by 11. And I'll get x is equal to 4. So I would take that 4, plug it into the original problem, and check it, and to verify that I got the correct solution. Okay, this will be our last one. This one is, we've got variables on both sides and we have constants on both sides. Now it doesn't matter how we do this. I could start by, I could subtract 7x from both sides and put all my x's onto the right. I could subtract 5 from both sides, put my variables on, or all my constants over here. I could also subtract 12 from both sides and put my constants over here. And then I could just choose whichever I want to start with. I want to keep my variable terms positive. So if I subtract 4x from this side and this side, I'm going to end up with 3x's over here and 0x's over here. And this will be a positive x or a positive coefficient for my variable term. So I'm going to subtract the 4x from both sides. I'll start with that. So I'll subtract 4x here and here. So now I have 3x plus 12 is equal to 5. Now I need to basically undo everything that's happening to x now that I've successfully isolated the x on the left-hand side. So I am adding 12 and multiplying by 3, so I'm going to subtract 12. I'm not sure if you can hear, but in my background, my cat is going absolutely nuts in this room right now. So I'll subtract 12 from both sides, and I will get 3x is equal to, this is negative 7. And then I will divide both sides by 3, and I'll get x equals negative 7/3. So that's my solution there. And you can plug it back in, check your answer, and there we go. So if you have any questions on any of these, bring those to class, and we'll talk about it, or email me, whatever you need to do. Just make sure you get your questions answered, and we'll talk later.